months because it is very strong and dominant over winter. Yes, in reality, it is part of one pressure belt, the high pressure belt that you find, and then the subtropical high pressure belt. But it is more intense during winter and weakens in summer. We say this pressure cell regulates air movement into the interior in different seasons. Like in winter, like we said earlier on, it stops influx or movement of air into the interior. But in summer, because it is weakened, it allows warm air from the South Indian high pressure cell to move into the interior of our country. Now, how is winter in South Africa? Now, winter months, this is what we expect to see in winter over the interior of our country. We have temperatures that are low. You'd have cool, dense air that sinks, always sinking into onto the interior. As the air sinks, it is compressed and heated adiabatically. We are going to discuss this adiabatical heating later on, but let us move on this one. It causes the lower layers to be warmer than those above them, and as a result, you have an inversion layer or an inversion that is formed over the escarpment. As a result of the air sinking, the pressure system rests on the escarpment. It acts as a lid and prevents warm, moist air from moving in, the air that is from the Indian Ocean. It causes the interior to experience dry winters, that is the Kalahari pressure. Now let us look at this drawing. Remember, grade 12s, in the past examinations, you've had to draw this drawing, whether it's either summer or winter. But please, don't forget, if the inversion layer is lower, it's below the escarpment, you know that it's winter conditions. And then you'd see there, moist air is blocked by the inversion and it cannot reach the interior. What is the result thereof? We do not have rainfall over the interior of the country in winter. You'd have, like we said earlier on, you'd have dry, sunny, cloudless days over the interior in winter. Let us look what happens in summer over South Africa. In summer, you have air that is warmer. Remember, before we move on, we are going to say in summer, because the high pressure cell is weakened. Now it says the inversion will occur above the level of the escarpment. The result thereof will be that warm, moist air can flow freely into the interior. And then that's why you would say in summer we experience summer rainfall. Look at the picture, the drawing there. It shows you what happens in summer. You see now the inversion layer has lifted, and then you say warm, moist air can move over the escarpment, cloud formation, and results are rainfall in summer. Fine. Let's move on, colleagues, and grade 12. Seasonal weather and climate conditions in South Africa. Let us look at summer conditions. What happens in summer over South Africa? I think everyone should know by now that in our examination guideline, we have a topic that we need to know and master, the topic on line thunderstorms. This is a phenomenon that occurs in summer over the interior. Remember I said in summer, because advection of moist air is possible, then you have rainfall. But what type of rainfall? Mostly you have thunderstorms that occur over South Africa. How do these thunderstorms occur? Remember, we said on the eastern part of our country, we have warm air that is moist moving in, and this warm air moves over the Mozambique current. You understand, as this warm air reaches the interior of our country, it is warm and moist. Remember, we call this wind that blows into the interior of our country, we call it the northeasterly winds. They are warm and moist. The result thereof is that you have warm, moist air, the northeasterlies, coming into South Africa. We say these are the warm, moist, northeasterly winds. Why we call them the northeasterly winds? You look at where, at the point of entrance into the interior, they come in the direction of the northeast. Why do they take up that direction? It's because of the circulation. Remember, circulation at this high pressure cell is anti-clockwise. So as it moves over the interior, it comes in to the northeast. We say these are the northeasterlies, which are warm and moist. And on the western side, you have air circulating around the South Atlantic high pressure cell, that as it blows into the interior, it moves over the cold Benguela current. The result thereof is that you'd have wind that comes into the interior of our country that we call the southwesterly winds. These winds are cold and dry. Now, these two air masses, or these two winds, as they blow into the interior of a country, they meet at a point that we call a moisture front. Grade 12s, remember, when you did your mid-latitude cyclone, you did talk about this concept, a front. We said a front is an imaginary line that separates two air masses. But let's not forget what happens when a front, when two air masses with different characteristics meet over a front. Obviously, remember, the cold air will force the warm air to do what? To rise. And the result thereof in summer over the interior of our country, you'd have thunderstorms occurring where? It's very important. These thunderstorms occur on the eastern part of our country. And then we call these thunderstorms the line thunderstorms. What's important again about these line thunderstorms is that, remember, you need to know what are the positives of these line thunderstorms. Just a picture that shows lightning there and the thunderstorms. Look, we need to know what are the positives. We say they are positive because you'd have rain over the interior in summer. And then we say because of these thunderstorms, you are able to have more water for irrigation. And then again, what might be the negatives? Remember, because they are accompanied by lightning, this lightning may kill people, it may burn sometimes vegetation, and it may burn houses. And then because of the intensity of rain, we might experience flash floods that may cause crops to be lost. That is one thing that we need to remember. Don't forget, I just need to go back a bit. Line thunderstorms are summer conditions. They are a result of the northeasterly winds and the southwesterly winds meeting at the moisture front. That is a convergence zone over the interior of our country. And the result is when these two air masses meet, warm air is forced to rise, and then you have cumulonimbus clouds forming, and then the result will be thunderstorms, which we call line thunderstorms. That is important. But what also happens, what happens in winter? Remember, in winter over the country, we said no advection of warm air. Now, you'd have what? In winter, you'd have a high pressure cell over the interior and a coastal low along the coast of our country. Now, ahead of the coastal low, you'd have the offshore winds that blow from the interior towards the coast. We call these winds, we call them the berg winds. It's simple. Berg, it's an Afrikaans word that means mountain. We say these are mountain winds because they originate from higher up in the interior, and it's wind blowing towards the coast. Why is this wind blowing towards the coast? Remember, grade 12, we said air always moves from areas of high pressure to areas of low pressure. So because there's a low pressure in the name of the coastal low over along the coast, and you have a high pressure over the interior, air will be moving from the high pressure cell towards the coast. And then we say this air, as it moves, we call the wind the berg winds. It's very important. For them to occur, don't forget, for berg winds to occur, you need to have a high pressure over the land and then a low pressure along the coast. This will cause a difference in pressure gradient, and the wind will blow from high pressure to low pressure. That is very important. Now, remember I said we are going to talk about adiabatic heating later on. Now, what happens to these berg winds? As these berg winds, remember, they move from this area. Look at the temperature there. It's 18 degrees Celsius. But as this wind blows towards the coast, look, as it reaches the coast, it's what? It's 28 degrees Celsius here. Now, what is this phenomenon? It says to us, as this wind blows down the escarpment in winter, they increase in temperature. They are heated by, the wind is heated by the surface over which it blows, and we say that process is adiabatic heating. What is adiabatic heating? It's when wind is heated as it blows down the escarpment. Now you'd see there's one important fact that says the temperature increases as air sinks by 1 degree for every 100 meters. So it means, what does this mean? If wind blows for every 100 meters distance that this wind covers, temperature increases by 1 degree Celsius. So it's very important to understand what adiabatic heating is, because remember, you'd have situations where you'd be asked, now, why is the temperature at Port Elizabeth 28 degrees Celsius, although it's winter? You are going to say, no, it's because the wind was heated as it was blowing down the escarpment. The other thing that's important for you to remember, don't forget, even though the temperatures are high here, you have no cloud cover. Why no cloud cover? Because it is sinking air. The air is sinking down the escarpment. So you don't have cloud cover. That is the berg winds. Let's move on. Now, what is the impact of these berg winds over the interior of our country? Remember, we said you have a high pressure over the interior. You have a low pressure over the sea, the coastal low, and then you start to have anti-clockwise, and then wind will be blowing towards the coastal low. You see, it's descending air that is blowing towards the coastal low. It's very important to note that these are warm, dry winds that are blowing towards the coast. Why do we say they are warm? Because they are heated as they move. Remember adiabatic heating. Why dry? Remember, it's air or wind blowing from an anticyclone that is descending and that is dry. Now, what is the result thereof? As a result, over the interior of our country in winter, we have a danger of veld fires. Why is that so? Because these winds are blowing very strong, don't forget. And in winter over the country, the grass or the veld is dry, there's no rain. So these winds, they help to spread the veld fires over winter in our country. And very importantly, as the cold fronts come in, as the mid-latitude cyclones come in, they are responsible for changing these conditions of the berg winds. Don't forget this one. What causes berg winds to dissipate? Mid-latitude cyclones are responsible for that these conditions, the berg wind conditions, are disturbed or are changed by the mid-latitude cyclones as they occur. Remember, this is also occurring in winter. Very important, very, very important, grade 12s. Now, let's move on to something else. Now, grade 12s, in our study, in every question paper every year, we also look at synoptic weather maps. Don't forget, you have to know what a synoptic weather map. Basically, it's just a summary of weather conditions in a day. If you look at that, you notice this is a synoptic weather map for 2006 on the 1st of January, on the 20th of January. This was drawn at 6 o'clock. What does this give? It tells us of a summary of weather conditions in a particular day over the country. It's important for us to be able to do what? We need to be able to interpret this synoptic weather map and to be able to say which seasons and we are and to tell what's actually happening in our country on that particular day. Don't forget, you see, the lines that show pressure on this synoptic weather map, we call them isobars. And then there you'd have all these things that we were discussing earlier on, your high pressure cells there, 1, 2, and then you'd have your coastal low pressure cell, and then you have all the other low pressure cells here. But you can tell, if you look at this, you'd see that there's your interior heat low. If we have this low pressure cell over the interior, look at the date, it's summer. Obviously, January is summer. But how do you see that it's winter on the synoptic weather map? Very importantly, to know and identify the season, any date that appears on the synoptic weather map that is between April and August, it says to you, now this was drawn in winter. That's very important. Fact number 2 that is important, in winter, we are going to see low temperatures over the interior of our country. So your synoptic weather map in winter will have low temperatures on all the weather stations that you see. Not unless that it's along the coast where you have higher temperatures because of berg winds conditions. Now, you have low dew point temperatures in the interior because there's dry air. Now, little or no cloud cover over the interior, cloud cover and rain over Cape Town. Remember, Cape Town is the only area in South Africa that receives winter rainfall because of its Mediterranean climate. So you notice that you won't have rain over other parts of the country, but in the Western Cape you'll have rainfall, and then it's winter. And then what else should you notice? Or what else should you look for? You look out for the berg wind conditions, prefrontal and the coastal low pressure cell. And then sometimes you'd find that in winter over the interior you have the cold front. We don't expect to see tropical cyclones in winter over the country. And lastly, you'd have your high pressure cell over the interior. That is what you need to look out for when you try and want to establish whether the synoptic weather map was drawn in winter or in summer. Now let's look at this drawing. Now look at your winter conditions. You see one, there's my mid-latitude cyclone. There's my Kalahari high pressure cell, that is winter. Now there's your South Atlantic anticyclone, and then you have your temperature inversion is below the escarpment. And then let's look at the synoptic weather map. Why we say this is winter. If you notice, let me go back. If you notice, there's my high pressure cell. And then most of the weather stations that you have here, they are, I just want to try and zoom this so that, yes, there, look at it. You'd see, let us look at the temperatures here. You will notice that there's my high pressure cell. Look at this Bloemfontein temperature, and Bloemfontein in this particular day, dew point temperature is -3 degrees. There is no cloud cover. Air temperature is 22 degrees. You see it's a huge difference. Then it says it's winter, low temperatures. We also said that we need to look out for occurrence of mid-latitude cyclones. Look, there's my mid-latitude cyclone over the interior. It's just going towards the interior. There's my rainfall over the Western Cape. You see, there's Kaapstad. Ne? Look at the rainfall there. Let me try and I want to try and zoom this thing. There, you see there's cloud cover there, it's overcast. We're expecting rainfall over the Western Cape. Then it says to us it's winter. So I'm sure grade 12s that those are the things that you will look out for when you try and check whether the season that is shown on this synoptic weather map, whether it's summer or winter. I said this is winter because you have your I lost something here. Okay, there I'm back. Technology does this at times. Now, you have your cold fronts, you have your rain over the Western Cape, and then there you have, no, this is, not doing what I want it to do. Yeah, this is where I want us to go. There you have your rainfall, and then there you have your high Kalahari high pressure cell over the interior. And then look at Durban, no rainfall, nothing. Look at the temperatures there. And then look at Port Elizabeth, there, no rainfall. So these are the things that you need to look out for. I was trying to find, so unfortunately this map that we're using today does not have a date. So no, there's the date there. I want to show you the date also, that you also need to look at the date. Look at the date on this map. It says 1999, 07, 14. Remember, I said between April and August, that will tell you it's winter. Let us move on. And summer, what is it that we expect to see over the interior of our country in summer? The first thing, the date, the synoptic weather map. If it's summer, you need to remember it should be between October and February. The dates there, that all the maps that are drawn between October and February will show summer conditions. You'd have high temperatures over the interior. You'd have your dew point and maximum temperatures in the interior within 5 degrees of each other. What does that tell you? It says to you there is moist air in the atmosphere. Once there's a little difference between maximum temperatures and dew point temperature. Now, the cloud cover over the interior, because we're expecting rainfall, you'd have quite a lot of weather stations having cloud cover filled with clouds. Now, we'll have little or no rain or no cloud cover over the Western Cape or Cape Town. Remember, I said Cape Town only receives winter rainfall, so we don't expect Cape Town to receive rainfall in summer. And then we don't have cold fronts over the interior. And then in winter, you should see tropical cyclones, and then you'd have a low pressure over the interior. Let's look at that. Now look at this illustration here. There's your tropical cyclone. There's your low pressure cell. The name of this low pressure cell over the interior in summer is called the heat low or the thermal low. Very important. And then this pressure cell may reach into the country in summer so that it brings moist air. But cold fronts, they usually do not come into the interior in summer. You see there, the cold front usually miss Cape Town. They miss Cape Town because they just down further south. That is important. And then you have your South Atlantic anticyclone. It would have moved further away from the subcontinent in summer. Let's look at the synoptic weather map that you expect to see in summer. Let us look at the conditions. Look the distance of the mid-latitude cyclone further away. Look at the South Atlantic high pressure cell. It's further away. There you have your tropical cyclone there. And then let us try and zoom and see if we can not see temperatures over the interior there. I want us to now, let's look. You will notice that there's Bloemfontein again. Temperature there is 19, dew point temperature 16. They are experiencing thunderstorms. I think we now know why you'd have the thunderstorms over the interior in summer. This is the result of the line thunderstorms that we discussed earlier. And also look at the date. I want us to look at the date. There, it says 1994-02 on the 18th. Then this was in February. These are the things that we need to look out for when we interpret a synoptic weather map. I just need us to recap before we finish. Let us say, what is it that I expect in summer? The date. We should have high temperatures over the interior. The dew point and maximum temperatures will have, there's going to be a little difference between dew point and maximum temperatures. The cloud cover, we are going to see clouds over the interior and most weather stations in summer, and then no clouds in Cape Town, and then we don't have cold fronts over the interior and the presence of the tropical cyclones. That is that. It's very important for us to be able to know how to interpret these synoptic weather maps, grade 12s. Let us for now pause and say good luck. I would like to wish you good luck, and this will be the end of our presentation today. Thank you, grade 12s.